Namaste. Let's start today's session. This is algebraic expressions. So let's do a quick overview, just for the sake of clarity. So algebra is basically an Arabic word. It's the origin is an Arabic word called algebra, and it is basically a generalized arithmetic, right? And the basic idea behind algebra is to represent mathematical statements with the help of a combination of letters and numbers. Just for example, if I say 4x squared, if I say 4x squared, right? If I say 4x squared plus 3x plus 2, then you see that there are basically some known values and unknown values, right? So what is known here? Known is basically the numbers, that is 4, 3 and 2, because their values don't change. 4 is 4, 3 is 3, 2 is 2. But this x that is associated with is an unknown value. Okay, so that is why they are called as variables. And the known values are called as constants, right? So basically, a constant is what we are familiar with in arithmetic, and what is the generalized in arithmetic is basically the unknown values that get added into algebra that we have to basically find, and together they make an algebraic expression. So let's say that this is an algebraic expression, 4x squared plus 3x plus 2, because you can see that it is basically the terms that are separated by the plus sign here. So an algebraic expression is basically a combination of terms, or that is variables and constants, using the mathematical operations like the addition, subtraction, multiplication and division, right? So another example of an algebraic expression is, you think of an expression as an English statement which is made up of words. So something like 2x plus 4y, right? So here it is basically 2 times x plus 4 times y, right? So this is an algebraic expression. Okay. So here 2x is called a term. So a it can be a constant. Let's say for something like 2, right? Or it can be a variable, let's say like x, or it can be basically a combination of both, right? Let's say 2x, right? So which actually gives me, the terms are basically the product, you know, of its factors. Like for example, I have got 2x. Now only when I multiply 2 times x, I get 2x. So we can say that 2x is basically the product of 2 times x. Now here since I have a term called 2x, 2 is called as, it is a constant. So here in this it is called as a numerical variable, or numerical coefficient. It is called as numerical coefficient, and x is called as a literal coefficient. Called as a literal coefficient, right? Now, if we have to add two algebraic terms or expressions, then we can only add like terms. So let's understand about like terms. So like terms basically are terms with the same variable. Let's say that I have 3x plus 4x. Okay. So here, what is more important for me in algebra is they both have a variable is same. So I can add them. So this will give me 7x. So this is very important because I can only add or subtract like terms. If you have any questions, you can ask me in the chat. Okay. So the first question in the quiz is fixed numerical values are called variables, right? It's a yes or no, true or false. So remember, let's take another example. Let's say 3x, right? So we have said that 3 is a constant, it's a known value. It is known. So that is why it's called as a constant. That means its value doesn't change, right? Okay. So can 3x a fixed numerical value? Okay. So this is called, x is called as a variable, correct? This is a variable. Let's take let's take an expression. Let's say x plus 2, right? So is this a fixed numerical value or called variables? Can 2 be a variable here? We know the value of 2, right? So that is why this is a constant. So a fixed numerical values are called variables is false. They are not called variables, they are called constants. Got it? Yeah. Fixed numerical values are called constants. Okay. Let's take another question. Constants can take various numerical values. True or false? Constants can take various numerical values. Yeah. Okay. So constants can take various numerical values. Can 2 here in this example x plus 2, can 2 take various numerical values, or is it x that can take various numerical values? So your answer is false, because a constant cannot take various numerical values because it is a known value. Got it? Constants can take various numerical values. The statement is false. Constants are always constants. It cannot take various numerical values. It cannot take any other value because that value is already fixed. Okay, let's take another question. An algebraic expression is a combination of variables and constants, right? An algebraic expression is a combination of variables and constants. Okay. So here is an algebraic expression. We have, let's take another one. We have, let's say, um, um, yeah, uh, 7x squared y plus 2x squared, right? Maybe minus 4, right? So here we have terms, we have three terms, and out of that, two are variables and one is a numerical term. So this is an example of an algebraic expression, right? So which contains both constants and variables, right? So this is an example of an algebraic expression, which is a combination of variables and constants and mathematical operations. Okay, so that is like plus minus, that is the symbols separated by the terms, right? Okay, good job. Okay, now next question. A term is a product of its factors, correct? Now let's take the same example. Let's take the term 7x squared y. This is a term, correct? Now, and this is also this is basically a one term, which is actually a product of 1 times 7 times x times y. When I multiply all these, I actually get 7x squared y. So we can say 7x squared y is a term, basically a product, okay, of 1, 7, x, and y. So your answer is true. Yes, a term is a product of its factors. Got it? Yeah. Okay. Good job. Okay. let's say, let's take another term, um, okay, 2x plus 3y, right? In the expression 2x plus 3y, right? 2 is called the numerical coefficient and y is called as the x and y are called as a literal coefficient, right? Okay, so the question here is 2 and 3 are the coefficient of the terms 2x plus 3y. So what is your answer? True or false? 2 and 3 are the coefficients of x and y, right? Okay. 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 Nice. Yeah. So let's understand a little bit about uh, uh, terms. It's a like term and unlike terms, right? So we have already discussed that. Let's do a quick recap. Like terms are terms that have the same literal coefficient, right? Let's say, for example, in this case itself, 2x plus 3y, we can't add them because we have x and y as literal coefficients. So they are different. We can't add them. They are unlike terms. So it doesn't matter what our numerical coefficient is. It doesn't matter. Even if it's a, let's say, 2x plus 2y, still we cannot add them because our variables here, that is the literal coefficients, are different. So we can't add them. So it will still be equal to 2x plus 2y. But if I had 3x squared plus 4x squared plus 2y squared, then here what I can do is I have two same literal variables. All I have to do is I just add the numbers there, that is 3 plus 4 x squared plus 2y squared. So that will give me 7x squared plus 2y squared. And I leave it at that. That's the final answer because I have the literal variables here are different. So I keep it that way, right? So this is about the like terms and unlike terms. Now let's come to types of algebraic expressions, right? Types of algebraic expressions. So which is basically based on the terms, basically. So let's say that I have a type of algebraic expression type, then say number of terms, and then let's say take an example. Okay. So one type of an expression is called as a monomial expression. Okay, monomial expression. So the number of terms in a monomial is actually 1. So there will be only one term. So some of the examples for that is, let's take 7x squared, right? Is one example, right? Minus 5 is another example, right? Um, um, x by 2 is one example, right? This is the first one. So then let's go to binomials. So binomial will have a binomial expression will have two terms, again separated by the arithmetic operators. So let's take an example like, so we have here 3x squared plus 4x squared, correct? There will be only two terms, right? That's just one example. And then we have a third one which is called as trinomial. It will have three terms, which will have three terms, again separated by the arithmetic, operators. Let's take, for example, a plus b plus c, right? Three terms. Then we have something called as a quadrinomial, okay? QUAD, quadrinomial. Quadrinomial means basically 4. So this will have 4 terms. So this will basically, you'll have, let's take it as a squared plus b squared plus c squared plus, I'm just giving you a random numbers, plus 4, just random terms, right? So quadrinomial. So we can go on like this, but then we give something called as a polynomial. Polynomial, basically it says, more than 2 terms, basically. Anything that is more than 2 terms is called as a polynomial. So yeah, we really can't give an example for it. I mean, all these are examples. Anything beyond quadrinomial is also an example of a polynomial. 5 terms, 6 terms, 7 terms, right? So anything, more than 2 terms is called as a polynomial. Got it? Now let's take a question, right? So 2x plus 3y, 2x plus 3y minus 4z is a trinomial expression. So just check how many terms are there in the expression. Trinomial is 3. Yeah. Okay. The answer is correct. It is a trinomial, right? We have 2x plus 3y minus 4z. So we have 3 terms. There are no like terms to add. All are different unique terms with unique variables. So that is why this will become a trinomial, an example of a trinomial expression. What about what about what about let's just change that, 2x plus 3y plus 4x, right? We can actually add, as you can see here, I have x and x over here. So I can actually add it looks like at first sight, it looks like a trinomial. But then I have two terms with the two like terms. So what I can do is I can just add 2 plus 4x plus 3y. So this will give me 6x plus 3y, which actually becomes a binomial. Correct? So now that takes us to a next question. 3x plus 3a. 3x plus 3a is an example of like terms. Is that an example of like terms? Yes, a polynomial has more than two terms. Yes, yes. A binomial, it is a binomial because when we add it, we get two terms. So 3x plus 3a is an example of like terms. No, it is not an example of basically like terms. It is 3x and 3a have two different variables, so they are not like terms, right? They are not like terms. They are unlike terms, so we can't add them together, even though the numerical coefficient is same, 3 in both the cases, but we can't add them. Okay, got it? Okay, let's go to something called as a degree of polynomials, right? Degree of polynomials. So remember, when we say 2x plus 3y plus 4, 2x is basically raised to the power. So this is an example. You can see that I have two variables here, x and y, right? So a polynomial may have one or more, or it can have even two or more basically types of variables. So this is an example of a linear equation. So we call it as a linear equation because the degree, the highest degree is actually 1 in both the cases. So 2x, that is x raised to the power 1, and then y raised to the power 1. So this is actually called as a linear equation. We'll come to that later. Linear equation. And since it has got two variables, that is x and y, so we say that it is a linear equation in two variables. And the degree is 1, correct? Because this is the degree. Your exponent or the power tells you what is the degree of the polynomial, right? So this is a linear equation in two variables, and the degree actually is 1. Let's take an example, another example. Let's say I have 2x to the power 3 or 6x cubed. So here the degree is 3, right? So the degree here, degree of polynomial 2x cubed is actually 3, right? And then let's say I have 4. Let's say 2x cubed plus 4. So the degree here is again 3, but then 4 has basically, it is 0. It's a constant term. So the degree of the constant is 0. Okay. Let's take another example. Let's say I have 3y to the power 5. So the degree of this polynomial, that is 3y to the power 5, is 5. Simple, right? Now let's do some addition and subtraction of some terms. Let's say just do like terms, right? um, let's say I have 2x squared plus 3y squared, right? Let's say I add, and 3x squared plus 4y squared. Okay, there are two methods to this. So method one is basically your horizontal method. So your horizontal method will be like 2x squared plus 3y squared. And I can just represent it in a different, like this, because I'm adding it. Or method 2 is column method, so where I actually group them together, right? Plus take here, 3x squared plus 4y squared. So when I group them together, it becomes easier for me to add the like terms. So I leave out because they are all same here. So I have x squared and x squared. So anyway, it is an x squared, and here it is y squared and y squared. So here it is y squared, and with that the plus sign here in between. So now I add 2 plus 3 is 5, 5x squared. 3 plus 4 is 7y squared. So this is how I can add the like terms, right? And I can do the same thing in for subtraction also. But for both addition and subtraction, we need to keep in mind that we can only add or we can subtract only the like terms. If the terms are different, if that means the variables are different, we can't add them. Let's take a question. Is 7a minus 2a, the difference is 5a. Is it true or false? Let's take that again. This is subtraction, right? 7a minus 2a. Okay. There is one rule in subtraction, that whenever we are subtracting, whether it is like or unlike, I mean, we can't really actually subtract an unlike term. So whenever we are subtracting, terms in algebra, we basically interchange the signs. So now I have a positive sign here, right? Even though I don't write a plus sign, I don't write a plus sign, I don't write a plus sign there, but it is still understood. It is still understood that yeah, I hope you can hear me now, right? So let's take a question. Um, okay, so we were doing subtraction, right? So 7a minus 2a, right? Now, when we are subtracting terms, we have to change, or we have to interchange. We have to interchange the sign. So here it is a plus sign, that is a positive 2a. So it is a plus sign there, which is like, hidden in that. But then what we have to do here is we have to change that sign to a negative sign, a minus sign. So now it becomes 7 minus 2a. So it will be 5a. So here the answer is 5a, not 9a. If I had done 7a minus of minus 2a, that means I have to subtract negative 2a from 7a. So how will that happen? So 7a minus negative 2a. So here my negative sign becomes positive. So it becomes basically plus, that is 2 positive 2a. So now it is 7a plus 2a will be 9a. So we just have to interchange, because here is, we just have to interchange the sign of the subtrahend. That's the only thing that is different from addition of like terms, right? Okay. I think we can end it for today. If you have questions, we can take up some questions. Uh, we can take up some questions. You can type your questions if you have any. Okay. Yeah. Take care. Have a good day. Bye.